The German and British military were the first in the world to put jet fighter aircraft into actual combat, but there were more than just these two countries conducting relevant research and development at the time. The United States also had a significant presence in the aviation field, and the MX-365 developed by the Army Aviation Corps was a very interesting rocket/jet fighter aircraft research project. John K. Northrop established the Northrop Company in 1939, which was initially famous for designing and manufacturing high-quality gliders. However, John K. Northrop himself was a visionary who realized that future aircraft would develop in the direction of non-propeller propulsion. He proposed a light interceptor with rocket propulsion and submitted it to the Army Aviation Corps in September 1942. For this new type of aircraft, those high-ranking officers were not unfamiliar, as they had already more or less been involved in related research. In January 1943, Northrop Company signed a contract with the Army Aviation Corps to manufacture 3 prototype aircraft for testing, with the company designation XP-79 and Air Force designation MX-365. In the initial design plan, the XP-79 was to use a single-release system and a Aerojet XP-2000 rocket engine, a liquid-fueled engine using a 3.5:1 ratio of red fuming nitric acid and aniline. It had 4 combustion chambers, with 2 generating 750 pounds of thrust each and the other 2 generating 250 pounds, for a total of 2,000 pounds of thrust. To assist with takeoff and landing, 2 additional 1,000-pound jettisonable booster rockets were to be installed on the aircraft. At the time, this rocket fighter was considered feasible, as jet engines were not yet mature, and rocket engines could provide stronger thrust. The aircraft had a flying wing design, was a single-seat rocket-powered interceptor, and weighed approximately 2,000 kilograms empty, with a maximum takeoff weight of about 6,100 kilograms, most of which was fuel weight. It was armed with 2 12.7 mm machine guns on each wing, with 250 rounds per gun. The fuselage was made of welded magnesium alloy skin rather than conventional aluminum. To accommodate larger overloads, the pilot actually controlled the aircraft from a cockpit lying on the central axis. The aircraft was expected to have a maximum flight speed of 518 km per hour and a maximum range of 454 km. Unfortunately, Aerojet's rocket engine was delayed, and the first 2 prototype aircraft were built but were waiting for the engine to arrive. In order to avoid delaying progress, Northrop Company had no choice but to find a 200-pound thrust rocket engine and make some modifications to the third unfinished prototype aircraft. As a result, the third prototype aircraft became the first powered glider test aircraft by accident. The 200-pound thrust engine only assisted the aircraft in gliding and verifying some basic flight performance, and did not fundamentally solve the problem. The military gradually became impatient with the project, and in the spring of 1943, the third prototype aircraft was modified again to accommodate the J-30 turbojet engine designed by Westinghouse Electric Corporation, and the aircraft with the new powerplant was renamed the XP-79B project. At a meeting in June of the same year, the evaluation committee believed that the XP-79 rocket aircraft still had advantages in climb rate and flight altitude, and the XP-79B's turbojet engine could not surpass it for the time being, so both sub-projects were allowed to proceed simultaneously. Although the military still supported the research, the MX-365 project as a whole was hampered by the delay in the engine, leading to many test flights being unable to take place. By the end of June, Northrop Company simply subcontracted the third prototype aircraft and the XP-79B project to Avion Company. Northrop Company continued to conduct related research on the first 2 prototype aircraft and used a P-38 to tow them into the air for release. The aircraft flew smoothly under the power of the 200-pound rocket engine, and the experiments went relatively smoothly. As for Avion Company, Aerojet's 2,000-pound rocket engine and Westinghouse's turbojet engine were constantly delayed, and they suffered great losses, leaving only the XP-79B project intact. The XP-79B prototype was finally completed in 1945, and in August the Westinghouse engine finally arrived. After installation, the aircraft performed well during flight tests, and the pilot even boldly performed some aerobatic maneuvers that could only be done after the aircraft had matured. However, the aircraft subsequently got stuck in a slow-speed high-angle spiral from which it could not recover, and crashed. Fortunately, the pilot successfully parachuted out, but no clear cause of the accident was found after a long investigation. By the end of that year, the US Army Aviation Corps realized that the entire MX-365 project was at a standstill, and therefore terminated the project. Although it was a pity that the project ended, this was not necessarily a bad thing. First, it must be acknowledged that the main reason the XP-79 did not develop smoothly was the lack of a rocket engine. From the Army's attitude towards it, there was no urgent need to deploy rocket fighters in the battlefield, but rather more exploration of non-propeller aircraft technology. As for the XP-79B, it was also hampered by the engine, and by the time it was ready for initial testing, many of its designs were already outdated, especially since the United States had obtained more mature technologies from Europe. Therefore, it was more straightforward to overturn those design projects that were not very promising, which was actually more decisive.